Since the dawn of time, an invisible war has been raging around us. A battle so small, most of us never see it, but it shapes the course of human history, drives scientific breakthroughs, and forces entire societies to adapt and evolve. This is the race between germs and humanity. In this ongoing struggle, both sides are constantly changing. Germs, microscopic invaders like bacteria, viruses, fungi, and protozoa, are endlessly evolving, finding new ways to spread, infect, and survive. Humanity, on the other hand, is always responding, developing new methods to fight back, from vaccines to antibiotics and even genetic engineering. But who's winning this war? Can we ever truly win against an enemy that adapts so quickly? Or is this a race that will never end? To understand the current state of this battle, we need to take a step back and explore the origins of germs, the major outbreaks that shaped history, and how the human immune system has evolved to cope with these threats. From the plagues of ancient Egypt to modern pandemics like COVID-19, the story of human survival is also the story of our own battle with germs. As we've seen, the history of humanity is inseparable from the history of germs. From the earliest plagues to modern battles against antibiotics resistance and emerging pandemics, we've always had to adapt in order to survive. And while medical science has come a long way, the race is far from over. It's important to remember that germs are part of our world. And the more we understand it, the better we can protect ourselves. Through his research, innovation, and global cooperation, we can continue to outsmart the microbes that have been plagued us for millennia. But we must never let our guard down. In the end, the race between germs and humanity isn't about winning. It's about surviving and thriving in a world where invisible threats are always around us. And as long as we keep pushing forward, we'll be able to stay one step ahead. Thank you for watching and see you next time. In the early days of human life, germs were an invisible but deadly presence. Small groups of hunter-gatherers lived in a relative isolation, which made it difficult for germs to spread. But that changed when humans discovered farming. As agriculture took root, so did germs. The domestication of animals introduced new diseases, and living in close proximity with livestock meant humans were exposed to pathogens like never before. The rise of cities and larger communities also created the perfect environment for diseases to spread rapidly. Throughout history, pandemics have shaped human civilization. In ancient Greece, the plague of atheists killed nearly a third of the population. In ancient Rome, the Antonio plague swept through the empire, likely brought back by soldiers returning from distant campaigns. Perhaps the most infamous historical pandemic was the Black Death, the bubonic plague that ravaged Europe in the 14th century. It killed an estimated 75 to 200 million people, wiping out entire towns and alerting the course of European history. The Black Death wasn't the only devastating epidemic to affect humanity. In fact, the history of human civilization is marked by outbreaks of disease that wiped out large portions of populations. From smallpox, which ravaged in the Americas after European colonization, to cholera outbreaks in the 19th century. Germs have always been the ultimate opportunist. exploiting human society's growth and interconnectedness. One of the most tragic examples of this occurred when Europeans began exploring and colonizing the Americas. The indigenous population of the New World have never ever been exposed to diseases like smallpox, milices, and influenza, which had circulated in Europe for centuries already. With no immunity, these germs decimulated Native American communities, leading to mortality rates as high as 90% in some areas. This pattern repeated itself again and again throughout history. Wherever humans traveled, they brought their germs with them. And in many cases, the germs traveled faster than humans. The Spanish flu of 1918 was one of the deadliest pandemics in modern history, killing more people than World War I in just over a year. It spread rapidly due to increased global travel as soldiers returned home after the war, bringing the new virus with them. But as deadly as these pandemics were, they were also a wake-up call for humanity. Each outbreak forced people to rethink sanitation, healthcare, and how societies function. Cities were redesigned to improve hygiene, water, and waste system were overhauled, and medical research took on a new urgency. So, what exactly are germs? To put it simply, germs are microorganisms that causes disease. There are four main types: bacteria, viruses, fungi, and protozoa. While they may be small, their impact on human life is anything but. Bacteria are single-celled organisms that live in a variety of environments. Some bacteria are beneficial, helping with digestion or decomposing organic material. But others can cause diseases like tuberculosis, pneumonia, or strep throat. Viruses, on the other hand, are even smaller and can't survive without a host. Once inside the human body, a virus hijacks healthy cells, forcing them to produce more viruses. Diseases like the flu, HIV, and more recently, COVID-19 are caused by viruses. Fungi, such as molds and yeasts, can also cause infections, particularly in people with weakened immune systems. And protozoa, microscopic parasites, cause illnesses like malaria by infecting the bloodstream. Germs can spread in a variety of ways: through the air, in water, on surface, or through direct contact with infected individuals. A single sneeze can release thousands of virus particles into the air, allowing diseases to travel quickly from person to person. Once inside the body, germs face their first challenge, the human immune system. But more on that later. First, let's talk about how germs evolved and became so efficient at spreading in the world. While germs have been evolved to spread and infect, the human body has developed an equally sophisticated defense system, the immune system. This complex network of cells, tissues, and organs works together to protect the body from invaders. But how does it work? The immune system has two main parts: the innate immune system and the adaptive immune system. The innate system is the body's first line of defense, always on alert for invaders. It includes barriers like the skin, mucous membranes, and stomach acid, as well as cells like neutrophils and macrophages, which patrol the body looking for signs for infection. But germs are sneaky, and sometimes they make it past these defenses. That's where the adaptive immune system comes in. Unlike the innate system, the adaptive system is specific and remembers previous infections. When a germ invades, special cells called lymphocytes spring into action. B cells produce antibodies, proteins that specifically targets the invader. Once an antibody locks onto a germ, it marks it for destruction, allowing other immune cells to come in and eliminate it. T cells, on the other hand, either help B cells or directly attack infected cells, making sure that the infection is contained. One of the most remarkable things about adaptive immune system is its memory. Once the body has encountered a germ, it remembers how to fight it. This is how vaccines work. By introducing a harmless piece of the germ, like a dead virus or weakened bacteria, the immune system learns how to respond without the person actually getting sick. Vaccines have the same saved millions of lives by teaching the immune system to recognize and attack germs before they can cause serious illness. Diseases like smallpox, which once killed millions, have been eradicated thanks to vaccines. Polio, another devastating disease, has been nearly eliminated worldwide. But germs are constantly evolving, and they are not easy to beat. Just as the immune system adapts to fight them, germs mutate to evade the body's defense. This brings us to one of the biggest challenges of our time: antibiotic resistance. As medical science advanced in the 20th century, antibiotics became one of the most powerful tools in the fighting against bacterial infections. Penicillin, discovered by Alexander Fleming in 1928, revolutionized medicine, turning once deadly infections into treatable conditions. Bacteria are incredibly adaptive. Over time, some strains of bacteria have developed resistance to antibiotics. These so-called superbugs can survive even the strongest treatments, making infections harder to treat and potentially deadly to more death from previous manageable diseases. Superbugs like MRSA and drug-resistant tuberculosis are becoming more common. Without new antibiotics, we risk turning into an era where a simple cut could lead to a deadly infection. But bacteria aren't the only threat. Viruses too are evolving. The global HIV/AIDS epidemic, which began in the 1980s, showed how deadly a virus could be when it spreads unchecked. In more recent years, diseases like Ebola, SARS, and COVID-19 have shown how quickly viruses can spread across the globe, especially in today's interconnected world. Fortunately, medical science has continued to fight back. New developments like mRNA viruses have given us powerful new tools in the battle against viruses. The COVID-19 pandemic, for example, led to a rapid development of vaccines that were able to reduce the spread and severity of the virus. But the battle isn't over. As we develop new treatments, germs continues to evolve. The more we use antibiotics and antivirals, the more germs mutate to resist them. It's a constant race between medical science and microorganisms. It's a race between science and nature, with both sides constantly adapting. So, what does the future hold in this ongoing race between germs and humanity? The truth is, we can't be sure. But what we do know is that as long as life exists, germs will continue to evolve and humans will need to find new ways to fight back. One promising area of research is genetic engineering. With tools like CRISPR, scientists are working on ways to edit the genes of viruses and bacteria, potentially stopping them from infecting humans altogether. There's also ongoing research into new types of vaccines and treatments, including personalized medicine tailored to an individual's genetic makeup. But germs aren't just a problem for the future, they are also a part of our past. In some areas, even rediscovering ancient germs that have been frozen for millennia. As climate change causes permafrost to melt, long dormant bacteria and viruses could be released into the world once again, posing a new threat to human health. And while science and medicine will continue to evolve, so will the challenges. Germ warfare or the use of biological weapons is another concern for the future. Advances in technology could make it easier for harmful germs to be engineered and deployed, making the need for robust global health systems even more urgent. The race between germs and humanity is one what's been going on since the beginning of human existence. While we've made incredible progress in fighting diseases, the future will require even more innovation, cooperation, and willingness. After all, in this race, there's no finish line, only the next challenge.